Hey boys and girls, welcome back to another edition of Crush Lusher Television. Okay, so this is one also from College Board. It's a implicit differentiation problem. So you got part A, B, C, and D. So just like you're going to have on the AP, you're going to have multiple parts. You're going to do it on a separate sheet of paper and you're going to upload it. Quick plug, if you have not seen this already, your AP exam updates narrated by Ms. Pierre Floyd, please read it. Any questions, please text me about all the information. More information about the calculus specific should be upcoming. Okay, so watch that. Make sure you fill out the Google form that goes with it about all your stuff, and you get your AP number and all that. Now, let's do this. A, B, C, and D. Do the best you can right now. Ready, set, go. All right, let's see what happens. Oh, not working right now. Does it want to work? Yeah. Here we go. Bam, there it is. Okay, so it gives you this curve, which is some crazy curve, and it wants to get the slope. So I got to get this slope to look like this. So it gives me a target to achieve. Okay, I got that. So I need to find the derivative. So this looks like I'm going to do the chain rule. So derivative of the outside. Keep the inside, bam, times derivative of the inside, which is 2, what? What's the derivative of y? Yeah, dy dx, cool. Minus, what's the derivative of negative 24x? That would be negative 24. What's the derivative of negative 3? That would be 0, cool. Okay, so let's clean this up a little bit. This is like 3 times 2 is like 6, right? 6 times 2y plus 1 squared dy dx. And this 24, I'm just going to add it to both sides right there, equals 24. Did you get this when you tried it on your own? I hope you did. So what am I going to do last? I'm going to divide all this fun stuff. 6 divided by 2y plus 1 squared. Because that means I have dy dx by itself. 24 divided by 6 is 4. You can do 24 divided by 6 is 4, and then 6 divided by 6 is 1. You can do that too if you want. And then this is 2y plus 1 squared. Cool, got it, part A. Thank you very much. Got it. Okay, so now what do we need next? We need to find the tangent line at -1, -2. So what do we always need for a tangent line? We need a point, right? So we need our point. We got -1, -2. Got it. Okay. Now we need the slope at -1, -2. So here's the slope, right? We just got that. Someone's going to plug it in here. So your slope, dy dx, is going to be 4 divided by 2 times, what's the y value? Because that's the y, right? That would be -2 plus 1 squared. Bam. Okay, so that's going to be 4. 2 times -2 is -4, plus 1 is -3 squared. So it's 4/9 is your slope. Cool. So it gives you the point and the slope. You're good to go. Y plus 2 equals 4/9 times the quantity x plus 1. Bam, part B. Got it. Cool. All right. So we got to get part C, d squared y over dx squared. So this means the second derivative. So I got the first derivative, I got to get the second derivative. So I got to derive this thing right here. So I derived the original function to get this right here. And I'm going to derive this to get this in part C. Cool. All right. So dy dx equals 4 times 2y plus 1 squared. Okay, so the derivative of this is d squared y over dx squared, which is the second derivative. Okay, so this I'm going to rewrite as 4 times 2y plus 1 to the -2, just so that helps me do the chain rule. So I just wrote this. This is the same thing, because when you have 2 on the denominator, when you bring it to the numerator, it's a -2. It's unhappy now. So now I'm going to do the chain rule. So -2 times 4 is -8. Keep the inside, 2y plus 1, minus 1 from here, so that's -3. Times derivative of the inside, which is 2, what? Yeah, dy dx. Cool. All right. Nice job. So this is negative 8 times 2, which is negative 16. dy dx is on the numerator. And then bring this to the denominator. 2y plus 1 to the third power. Now I need to evaluate this at this point, negative 1, negative 2. That's what it says. So dy dx at that point, you already did that right here. We already did that. We already plugged in negative 2. So we already evaluated dy dx. So this part right here is 4/9. Cool. So that's negative 16 times 4/9. Boom. Now the y is also going to be negative 2. So I'm plugging negative 2 here. So it's 2 times negative 2 plus 1 to the third power. In this case, to the third power. All right. So negative 16 times 4. 16 times 4. You can use a calculator when you do this on your AP. 4 times 2, 6, 64, and negative, so it's negative 64 over 9. And this is going to be negative 3 to the third, which is negative 27 over 1. So now I simplify that just a little bit more. So that's going to be negative 64 over 9 times the inverse, which is 1 over negative 27. 27 times 9, see if I got my calculator ready, yeah. 27 times 9, it's 243. So it equals, so negative divided by negative is positive. So it's positive 64 over 243. You can leave it like that if you want. You actually could have left it like this if you wanted to. And that would be correct. But I think that's the final answer right there. Cool. All right, I think we got time for part D. So part D is a little confusing. We haven't really gone over this that much, but it's actually pretty simple. So this wants, so y to the negative 1 here. So this means inverse. When you see that negative 1 power, rather than y to the negative 1, that means your inverse. So you want the derivative of the inverse at 0. Well, the inverse of this is just you switch the x and the y, which is 0 and 1/6. So you want the inverse at the same point. So all you do is you plug this in to your derivative, and then it's 1 over the derivative. So it's essentially just 1 over this derivative. Y prime of 1/6, You plug that in. So it's the same thing. So you're going to plug in, what we got? So we got y is 0 in this case, right? So you can plug in 0 here to your derivative. So you have dy dx equals 4 times 2 times 0 plus 1 squared. So that's 1 squared, so that's just 4. Boom. So the inverse is 1 over that derivative, so it's 1 over 4. So that would be the answer. Bam. So the derivative is 4, the inverse at that same point is 1/4. Cool, got it. All right, there we go. Good work, everybody.